in this example, we want to determine what is the integral f of x dx, given the function f of x is x squared plus x divided by the square root of x. Now this function is a little bit more complicated, and so to be able to apply our rules of integration, we want to rewrite or simplify the equation. To simplify f of x, we can do this in a few algebraic steps. So the numerator is x squared plus x. The denominator, the square root of x, is actually x to the 1/2. And I can rewrite this as x squared divided by x to the 1/2 plus x over x to the 1/2. So splitting it up into two terms, both terms have the same denominator. That's why I could combine it in the numerator in the first place. But now I can simplify each term. So x squared divided by x to the 1/2 is the same as saying x squared times x to the negative 1/2 and x times x to the negative 1/2. And then when we have exponents, when we have two terms with exponents that are multiplied together, the exponents add. So here I have 2 minus 1/2, and here I have 1 minus 1/2. And so we end up with x to the 1.5, which is 3 over 2, and x to the 1/2. So this is just a different form of f of x. I haven't actually changed the function. It is an equivalent form. Now, to integrate f of x with respect to x, I'm integrating x to the 3 over 2 plus x to the 1/2 dx. And this is the same as integrating x to the 3 over 2 dx plus the integral x to the 1/2 dx. And each of these terms, we can apply the power rule. So the integral of x to the 3 over 2 is x to the 3 over 2 plus 1 divided by 3 over 2 plus 1 plus some constant of integration. And then the second term is x to the 1/2 plus 1 divided by 1/2 plus 1 plus some constant of integration. And whenever we have constants of integration, you can combine them. The combination of any number of generic constants, I could call them 1 and 2, is just some other generic constant, so we can lump it into one C term. So to simplify this, 3 over 2 plus 1 is 5 over 2, divided by 5 over 2 is the same as multiplying by 2/5. So I have 2/5 x to the 5 over 2 plus 2/3 x to the 3 over 2 plus some constant of integration. And essentially what I've said is that C1 plus C2 is C. That's basic. That's implied. So this would be an antiderivative of the function that we started with above, and which we rewrote to make integrating not only simpler, but more approachable.